Hello everyone, this is Jonathan. He will be presenting on the thermocouple time constant experiment.
Hi, my name is Jonathan Andersson. I'm presenting the results from group 2 of our thermocouple time constant experiment. So for this experiment, we wanted to measure the temperatures of a transient system with a thermocouple. And for our experiment, we performed it with a cold water ice bath. And we performed both insertion and removal tests. For the objective of the experiment, we want to record the transient response of the thermocouple and use graphical results to estimate the time constants. And from there, we want to compare the results to both the other group's cold water experiment and the hot water experiment. For the theory, we assume that there are no internal thermal gradients, and then we use the lumped capacitance method. From there, we perform an energy balance on the thermal system, and from there, integrating with respect to time with the initial condition of T naught equals 0 at 0 seconds, we get this equation on the bottom right. And further, the time constants is the density times the volume and the specific heat over the convective heat transfer coefficient times the surface area. And that's the time constant. And if you plot the time against the natural log of the time minus the temperature minus the ambient temperature over the initial minus ambient temperature, we get the slope of negative tau, and that's how we find the time constant. For the equipment used, we use a 500 milliliter flask with ice water and a type K thermocouple and some paper towels and a computer with data acquisition software, as well as some other equipment. For the procedure, first we set up the experiment and the workstation, and we performed first the insertion transient test on the ice bath, collect the data, and then do the same thing for the removal transient test of the ice bath and collect that data and ensure that all the data is good before moving on. So here are the results for the ice bath insertion test. Plotting temperature against time, we can see that the ambient temperature ended up being about 3 degrees Celsius, and the initial temperature was about 23 degrees Celsius. If we normalize this temperature, basically getting the y-axis to go from 0 to 1 so that the data is more easy to understand, we get this graph. From there, we plot time against the natural log of the normalized temperature, which gives us a set of data points. And if we perform a linear fit on these data points, we get the slope of this to be, the negative of the slope of this to be the time constant, which was found to be about 4.2 seconds. If we look at the same graph but for the ice bath removal test, we see that the ambient temperature was about 21 degrees Celsius and the initial temperature about 2.7 degrees Celsius. Again, we plotted the normalized temperature against the time, getting the y-axis to go from 0 to 1 so that it's easier to read and understand. And then again, we plot this time against the natural log of the normalized temperature. We get these data points and we get a time constant of about 71 seconds. Looking at the data from the other group who performed the hot bath insertion test, we see plotting the time against the natural log of the normalized temperature again, they got a time constant of about 0.74 seconds for the insertion test. For their removal test, they got a much higher time constant of about 63, which is consistent with the data that we got as well. If we compare our data, which is the left side graph, to the other group, cold water group's experiment, we see that the time constants are pretty close to each other, and they are both lower for the insertion test compared to the removal test, which is much higher, as you can see in these two graphs, with our experiment being the left one. So in conclusion, we experimentally determined the thermocouple time constant by plotting the data and time against the natural log of the normalized temperature, and we used the lump capacitance method. And we can see that the removal transient test had a much higher time constant than the insertion test. And then we controlled as many variables as possible by doing things such as wiping off the probe when we removed it from the ice bath, so that the convective medium is consistent. Thank you.